So it turns out that beta cells are actually pretty bad at protecting themselves from oxidative stress. It has the research world in a bit of a tizzy because why would such a metabolically active cell, and thus one that creates a lot of oxidative stress, have no means of protecting itself? Beta cells are low in the naturally occurring antioxidants catalase and glutathione peroxidase. Catalase is something that breaks down hydrogen peroxide, which is a form of reactive oxygen species, into something more inert. And then glutathione peroxidase is something that helps regenerate glutathione, which is a naturally occurring antioxidant in the cell. So it's twofold. They can't break down reactive oxygen species as well as other cells, and they aren't able to regenerate other antioxidants to handle that oxidative stress. And this leaves them particularly vulnerable to some fairly common things, one of them being homocysteine accumulation, things like iron overload. It has connections to the gut, it has connections to liver function. But the question stands, why are beta cells so vulnerable? Why wouldn't they have better natural defense mechanisms? It seems like they create a lot of waste and they have no means of taking care of it. I've got a theory. And it requires you to see beta cells as part of a much larger oxidative stress buffering system. Because while the beta cells themselves may be vulnerable, there are a lot of protective mechanisms that are layered over the beta cells. So you start with your beta cells as your base layer. They don't have great natural immunity because, well, they're really busy. They're always on, they're always producing insulin, regulating blood sugars with the liver, going back and forth. Maybe they don't have great natural defense mechanisms because they need to conserve all of their energy for making insulin. But the other organs of the body have their back. So starting off, before we even get to the handling oxidative stress, you have to realize that the body has several different mechanisms to make beta cells or beta-like cells from cells that weren't initially beta cells. That's right. So alpha cells have shown the ability to convert to beta cells through a number of different means. Acinar and ductal cells, which are both exocrine cell types within the pancreas, they have to do with digestion and making pancreatic enzymes. They've shown ability to convert to beta cells. And even enterocytes in the gut and hepatocytes in the liver have shown the ability to convert to beta cells as well. Now let's talk about oxidative stress. I'm going to list out all of these layers. They are in no particular order of importance. This is just a visual demonstration of just how many levels of protection those beta cells have. So let's start with the liver. The liver is a main site of metabolism, storage, and distribution of nutrients imperative to cell health. You've got B vitamins and their role in mitochondrial health. You have iron and copper and their roles in iron regulation. Trace minerals like chromium, vanadium, zinc all play major roles in insulin sensitivity, in antioxidant activity. Magnesium has a role in literally every stage of glucose metabolism. And then you have your fat-soluble vitamins, A, D, E, and K. They are major immune regulators. They are major cell membrane regulators. If you're lacking in your ability to handle any one of those things, it is a major drain on your cellular health. Then you have to consider the liver's role in digestion, in bile production and fat metabolism, glycogen storage, and how intimate a relationship the pancreas has with the liver in making sure that our blood sugars stay stable. Healthy bile production from the liver helps absorb fat-soluble vitamins because you're able to digest fats better. This helps prevent lipid peroxidation, which is something that breaks down cell membranes, which can lead to immune activation. And it also ensures that the pancreas's digestive enzymes are able to flow freely. Because if those digestive enzymes get blocked by things like gallstones, that can lead to digestive enzyme backup into the pancreas, which causes inflammation. And then you have the liver's detox abilities, which is really what most people know it for. Now, for everything the beta cells lack from an antioxidant standpoint, the liver has like 10x that. superoxide dismutase, you have catalase, you have glutathione peroxidase. The liver is the main site of production of glutathione, which is the body's strongest antioxidant. Not to mention the liver's role in iron regulation. It is the main site of iron recycling. If we don't have the nutrients necessary to properly utilize iron, the liver is the first organ to wear it on the chin. And when iron isn't utilized properly, it's extremely toxic. And when the liver's iron stores gets filled to the brim, it starts to spill over and affects surrounding organs like the pancreas and the gut. And also, let's not forget that in that detox category is also things like pathogenic exposure, viruses, mold, fungi, bacteria. That all gets processed through the liver. And if the liver can't properly handle those environmental toxins, they slip through the cracks and create their own inflammatory cascades. And then you've got the gut. Everyone knows how important the gut is for immune health. It's impacting how well we absorb the nutrients that other organs need in order to function properly. It is this place where our microbiome takes hold and is able to have their immunoregulatory and their hormonal regulatory effects. I mean, GLP-1, GABA, serotonin, dopamine, those are all very important molecules when it comes to handling oxidative stress that gets sourced from the gut. And I mean, consider all of the things that are disrupting our gut health. Chronic stress and the resulting hormonal dysregulation. You have nutrient-poor food, pro-oxidant food. It's no coincidence that things like leaky gut, Crohn's disease, and IBS are all commonly associated with diabetes. Next, we've got the lymphatic system. Now, there's no place the lymphatic system doesn't touch. It has a role in gut health. It has a role in liver health. But it's important to know the roles it plays so we can see how important it is in managing oxidative stress. So the lymphatic system is where things like toxin flushing, waste removal from basic cell metabolism, immune regulation, it helps flush out the inflammatory cytokines. It even helps distribute the fat-soluble vitamins A, D, E, and K, which are antioxidants in and of themselves. Cell membrane repair lipids like cholesterol get transported through the lymphatic system as well. And fluid balance, maintaining the proper and healthy circulation of fluids. And this is impacting our electrolyte balance. Sodium, potassium, calcium, magnesium, major players in insulin release. Next up, you got the superstar of them all, the immune system itself, which again has its hands in all of the other systems, but also benefits from them as well. There's a certain synergy between all of these. And within that, we have our innate immunity, which is our natural killer cells. Innate immunity is like the immediate line of defense. Handle the disruption, ask questions later. Then you have our adaptive immunity. These are your T cells and your B cells. These are the initiators of the inflammatory cascade that so many of us are familiar with. Inflammatory markers like NF-κB, TNF-alpha, all of the interleukins. Then you have the thymus regulation and education. The thymus is this incredible immune organ that helps create T cells. It helps educate T cells to make sure that we are adapting to the pathogens that we take on. It's basically where all of our white blood cells go to school to learn what to take care of in the body. The immune system is absolutely incredible. But this is all to say that the slack that beta cells get for not having great defense mechanisms is completely bypassing the fact that we have an entire slew of systems above it that not only protect it, but also have the ability to make new ones. So if I were someone interested in addressing the inflammation associated with diabetes and perhaps preventing the successful proliferation of beta cells, you need to make sure that you're supplying all of these systems with the things that they need, and to recognize that the health of one impacts the health of the other. And to that same degree, failure of one leads to a much higher strain on the other. So with all of those layers of defense on top of beta cells, I'm willing to bet the beta cells were like, hey guys, listen, I got a lot going on in the metabolism department, making all this insulin all the time. You guys handle the defenses, keep me safe, and I'll make sure you have the glucose you need to keep running.